All right, so 6.1, verifying the trig identities. I'm just going to go ahead and rewrite your fundamental trig identities. You should already have these somewhere, but you can have them all in one spot if you decide to write them right here. All right, so these are reciprocal. Let's go reciprocal. All right, so your first set of identities are your reciprocal identities. Sine is equal to 1 over cosecant. Cosecant is equal to 1 over sine. Cosine is equal to 1 over secant. Secant is equal to 1 over cosine. Tan is equal to 1 over cotangent. And cotangent is equal to 1 over tangent. All right.
Okay, so for my own sanity, what are these for, really?
Talking about real life application.
Yeah, sure. Or, I don't know, just a basic explanation. I mean, reciprocal, what, as far as.
About a relationship between the, you talking about these relationships then. Okay, well, if you're just talking about the relationship, it's just what we're going to do in this section is that we're going to use these fundamental trig identities to be able to solve and show the equivalence from one phrase or one expression to another. These type of practices help you in calculus, and so and these and knowing how to do these in calculus helps you with a whole bunch of physical properties or physical application when you go into physics, or if you go into engineering, any of your major sciences lean on these type of thought processes and the trig and all that good stuff like that.
Cool, thank you.
Yep, no problem. As a matter of fact, I think we're going to get into some trig applications. Well, we saw it in chapter 5 how we can use trig in order to solve with the bearings and all that stuff like that. Uh, Triangulation and finding tangent line or different things. So we saw with the applications in chapter 5 and 5.8, 5.1. When we can use trig to help us find missing angles and different things like that, missing sides. So these are just though just relationships between the different trigonometric identities.
All right, cool.
All right, and then I think quotient identity, yeah. Oh, not cotangent. All right, so I could do a line right here. Your quotient identities. Tan is equal to sine over cosine. Cotangent is equal to cosine over sine. Let's see. Pythagorean identities, sine squared plus cosine squared is equal to 1. 1 plus tan squared is equal to secant squared. 1 plus cotangent squared is equal to cosecant squared. And yes, last set. All right, so our even and odd identities, even our two even identities, cosine of negative x is the same thing as cosine x. Secant of negative x is the same thing as secant x. And our odd identities, sine of negative x is the same thing as negative sine x. And then tangent, cosecant, and cotangent follow that same pattern of being or applying to a negative, and it's the same thing as a negative tan x. All
So
right.
when you're writing these out and you put the X, is that just that's just the letter you're using? Because I'm looking in the Larson book and they like to use U for some reason.
Yes, that's you can use that. Any variable can be used.
Okay.
Yep. A lot of times they'll use theta, Greek letter theta. So, yep. All right. So what we'll be doing in this section is just verifying that the statement that you're looking at is actually true. Um, for the most part, just looking through, they are not asking you if the statement is true. They're telling you guys to show it. So the option of this is not correct or this is not true will not be legit. So there's a turn that you guys have to make when you're talking about, hold on 1 second. All right. So there's a turn that you have to make when you're talking about transitioning from like arithmetic to algebra. There's a certain thought process that has to be made. Then the same thing going from algebra to trig, and then trig all the way to calculus. And the thought process talking about going from algebra to trig to calculus is that once you get all the way to calculus, the option of not getting an answer is not really an option. So you remember like when you could be factoring in algebra and you could write prime, and that means there's nothing you could do. Well, when you get into calculus, there's always something else you can do. It's going to be a very rare moment when there's nothing else you can do, because don't forget, under calculus, you have trig options, you have algebra options, you have arithmetic options, and so on. So you have all these different options that you've been building up, all of these different methods in your arsenal that you've been building up to get to calculus. And very rarely will you have a moment where there's nothing else you can do. There's so many different ways you can manipulate the problem in order to get the desired result. And so this is a process or a thought process or exercise that's helping you along in that thought process of they're telling you to verify this identity, and you have to use these different identities or whatever method you have in your arsenal to prove that this is true, that secant x times cotangent x is equal to cosecant x. So once again, they're telling us to verify it. They're not asking us, is it true? So somehow, some way, I need to make the left side look like the right side or vice versa. So one way of doing it, we can always try, because every time you try something doesn't mean it's always going to work. So you may have to double back and start from the beginning, start from scratch. And that is a part of the process. So convert each So one way of doing it is to convert everything or convert each term that you're working with to cosine to sine. And work also, especially if you're just beginning. Now, once you get comfortable with it, know what you're doing, know where you want to go, you might start fiddling around with both sides and all the good stuff like that at the same time. Or you work with one side at a time. And simpler. Let's do it. All right, so just a few things we can try to do. Like I said, just because you try to do it doesn't mean that it will always work that way or work out well for you. Sometimes you may have to flip what you're going to do, depending on how complex the problem is. So we want to convert each sine to cosine of sine, see if that'll work. Of course, you want to try to work one side at a time, and then try to work the more complicated side down to the less complicated side. So when I look at what's going on here, I would actually look at the secant x times cotangent x and see if I can turn it into cosecant instead of working with cosecant and try to expand it out to secant x cotangent x. So secant is 1 over cosine. Cotangent is cosine over sine. All right. And so I don't know if I talked about it in this class, but algebra is at the foundation of all of your sciences. I remember one professor was talking about, or one student was telling me about how a professor finally told him about calculus. He made it to calculus and he failed out. And the teacher told him that he didn't fail calculus, he finally failed algebra. And so your algebraic skills are key as you move forward in any of your sciences, because your algebra is sitting at the foundation of all of your sciences, whether it's biology, chemistry, calculus, higher maths, or whatever. I have a math problem in my office wherein it's 7 pages long, and only the first 2 or 3 steps are calculus, and the rest are algebraic moves. And so the reason why I bring that up right now is that we have secant times cotangent. We converted them to 1 over cosine, cosine over sine. So far, we are in trig. We've only made one move. That was trig. The next move that we make is considered algebra. We're going to cancel out cosine over cosine. And so that's algebraic. And that would be 1 over sine. And 1 over sine is cosecant. And that's what we were looking for. And so that's the foundation of what you guys are going to be doing in this section, which is verifying the identities, making one side look like the other side to prove that the statement is true. All right, so here we have 1 plus sine over cosine is equal to secant plus tangent. What we can do here, and some of this stuff will be less complicated once you see what your options are. As you see a few examples, you say, oh, okay, I didn't know I could do that. That makes sense. And so once you see the options, you will start to know what you can do and what you can't do and so on. So here, this cosine, if I want to break up the fraction, notice we have 2 separate terms. So if I'm looking to break up this fraction, I can apply that cosine to both top, I mean, not to both tops, but to each term in the numerator. So that would be 1 over cosine plus sine over cosine. Then using your identities, 1 over cosine is secant, sine over cosine is tangent. How did I miss that one? Okay. All right, so the next one. Sine x times tangent x plus cosine x equal to secant x. So you notice the thought process here is that I have 2 terms. You know, your plus sign separates your terms, plus and minus sign separate your terms. I have 2 terms here. I need to figure out a way to combine them because they're set equal to just 1 term, and that is secant. So we can go back to the idea of converting everything to sine and cosine. So I'm working this left side. Tangent is sine x over cosine x. So now I can simplify that first term. Sine times sine over cosine is going to be sine squared x over cosine. Now I have a fraction, so I can look to convert cosine into a fraction by putting it over 1. In order to add fractions, need a common denominator. So I will multiply top and bottom by cosine, because I have this cosine right here in my denominator of the first term. So it's sine squared x over cosine x plus cosine squared x over cosine x. Now that I have common denominators, I can go ahead and add them together. Here we have our Pythagorean identity. Sine squared plus cosine squared is equal to 1. And then 1 over cosine is secant. Questions.
This is whacked.
I'm sorry, sir.
The why still kills me.
Oh man. Well, depending on your major, you might not even ever get to an actual visual why. I just
What
remember
I
there
don't
was always.
understand.
Say
Like,
again?
who comes up with these? I'm going for occupational safety, industrial engineering, right?
Yeah.
I will never see this or use this again. But somebody smarter than me said, you need this to get a degree. Who? Like,
Well, maybe it's to make you more well-rounded. I don't know.
no, I think somebody was like, I had to do it, so screw you. So do you.
I say it is troubling to manipulate numbers for the sake of manipulation versus applying the math to determine a solution to a question. I'm pushing 40. I don't work out. I'm rounded enough. Oh, that was good. That's good. Well, yeah, like I said, these things right now we're doing them abstractly. There's no application here. So the why is not here. They're really setting a foundation so that you will be able to manipulate, these things when you get into the actual application of these. Let's see, just like 6.2, some difference formula, no, power reducing. Yeah, so all of the sections in chapter 6, we're not really getting into an application. We're just setting that foundation so that you can use it moving forward. So yeah, unfortunately, I'm sorry. Let me see what chapter 7 is talking about. Yeah, chapter 7, the law of sines. When we get into the law of sines, law of cosines, we'll get into applications. Um, yeah, I mean, still might not use it in your real life, but at least you would know where you could use it.
That's like when they tell you, oh, well, you should know how to do it because what if the machine breaks? Well, then we get the day off and you get the machine fixed. It's not, no. I'll be damned if any one of those bosses is going to sit there and mathematically work this out just so they don't have to go home for the day. Like,
This is true, sir. It's completely true. Oh man. Well, if an apocalypse ever occurred, then maybe they would need you to teach it to the children so that they can be able to progress and start a new civilization. So this next one, we have sine x minus sine times cosine squared x is equal to sine cubed x. So in this case, notice we have sine in both terms. We can actually try to factor out sine and see if that will help us. So we got sine x, that'll be 1 minus cosine squared x, sine cubed x. Well, normally I don't write that one over there since that's just the right side. But we have sine times 1 minus sine squared, cosine squared, excuse me. And this right here is the Pythagorean identity again. So sine squared plus cosine squared equal 1. I can subtract cosine squared from both sides. That's what that's supposed to be. And I'm looking at sine squared x is equal to 1 minus cosine squared. So sine x, 1 minus cosine squared is equal to sine squared x, which means sine times sine, sine cubed. And that's what we're trying to get.
just to clarify, in the purple all the way to the right, you kind of pushed it up against the edge. I can't make that out.
Yeah, that's cosine squared. What I did was I subtracted cosine squared from both sides. Still got it messed up. I'll just write it down here. So I had sine squared x, cosine squared x equal to 1. So if you were to subtract cosine squared from both sides, sine squared is equal to 1 minus cosine squared. So all I did was manipulate the Pythagorean identity. I use a different identity property. You got it. So, and got a right answer. My final answer was sine squared plus cosine squared. Now there are different ways of doing this, right? You could have used, I see what you're saying. Yep, you could have did that. There are going to be different ways. Now, some of them, there's only one way to do it, but most of them, there will be different ways that you can manipulate the problem. And what is the easiest way will just depend on what you see at the moment. You know, a lot of times just what you see that will dictate what was the easiest way to go. Divided by sine. Okay, yeah, that'll work. That'll work. Most of the time when you're introducing this verifying identities, they don't suggest I teach going across the equal sign yet, because we're just looking at, you know, foundational moves right now. But yeah, you can treat this the same way you would your you know, solving your regular equations to verify the left side to the right side. Yep. All right, so let's see another one. I know you guys want to see more. Can't wait to do more. Let's see, cosine. All right, so we have cosine over 1 plus sine plus 1 plus sine over cosine, and that is going to equal 2 secant x. So once again, this is the type of scenario where we're looking to bring our fractions. We have two fractions here, bring them together because we have one solid term on the right side. So we need a common denominator. Remember, whenever you're going to add your fractions, you need that common denominator. That's going to be 1 plus sine x times cosine x. So in the first one, I'm going to multiply top and bottom by cosine, because I had 1 plus sine x on the bottom already. In the next one, multiply top and bottom by 1 plus sine, because I already had cosine in the denominator. As far as the denominator goes, I'm not going to distribute that cosine. I'm going to leave it the way it is for right now. And that should, leaving it that way should be fine, should help me out moving forward. And you'll see what I mean in a second. So cosine times cosine is cosine squared, plus I will go ahead and FOIL this out. So 1 times 1 is 1, plus sine x, plus sine x, plus sine squared x. And down bottom, All right. So, a couple things going on in this numerator. Sine and sine would be 2 sines, so I can add those together. But also I have cosine squared and sine squared. I can add those together. So let me do this. Just gonna rewrite. Because remember, addition is commutative, so you can move your terms around. All right. So that cosine squared plus sine squared is equal to 1. That goes back to your Pythagorean identity. Notice if you don't remember all of them, at least remember that one. That thing done came up like 3 times already within our examples. All right, 1 plus 1 is 2. Also, if I look at what I have, I can factor out 2 from that numerator. And what I would be left with is 1 plus sine x. Now the quantities of 1 plus sine x can cancel for us. And I have 2 over cosine x, which is the same thing as 2 times 1 over cosine, which is the same thing as 2 times secant. I think that's what we're supposed to, yep, that's what we're supposed to get. And that's it. All right. Questions, questions, questions. All right. That's all this section is about. So let's do another one. Okay. All right, let's do at least one more. Let's go with all right, so here we have tan x minus sine of negative x over 1 plus cosine x is equal to tan x. All right, so let's see how this one will work out for us. So we have this left side that's way more complicated than the right side, so we'll try to work that down. First thing, recognize that we have odd function, odd identity. So that sine of negative x is the same thing as negative sine x. So now negative to a negative turns positive for us. All right, so we can turn tangent into cosines and sines. Cosine and sine, I should say, to try to see if we can bring it together with that sine. So remember, our goal right now is to get one single term, and we hope to make it a tangent. So let's simplify this numerator. Common denominator is cosine. So I need to multiply top and bottom by cosine. And I'll take it down bottom. All right, and that's all over 1 plus cosine. I don't have much room, so if I cover or remove something and you need to see it, just let me know. I'll take it back down. So bringing that top together, that's sine plus sine cosine over 1 plus cosine. All right. So, and once again, the more you do these, the more you see what you can do or what you should do according to your moves. I see here that I have a sign that I can factor out, but it really doesn't help me until I go into another way. So I'm going to rewrite my problem this way. So this divisional bar is the same thing as this divisional sign. So one is written vertically, the other one's written horizontally. All right, so whenever dividing by a fraction, you multiplying by the reciprocal. So I'm going to flip that, write 1 plus cosine over x in the denominator, the one on top. Now going back here, I can factor out that sign from each numerator, each term in the numerator. Now, since we're multiplying, I can cancel out the expression that's in the top, that's in common with the top and the bottom. And that leaves me with sine x over cosine x. And that is equal to tan x, which is what I needed. All right, questions? Any questions?
No, not yet.
And some of them may not pop up until you actually try them out. So if you try it out, get stuck on one, always feel free to bring it to class and we can talk about it, go over it in class and stuff like that. How much time we have? 24. We got 20 minutes. We can. I don't want to start a new section, so we can do. Let's do one more and then the 6-1 by itself. So let's see. So we have cosine minus sine squared plus cosine plus sine squared, and that is equal to 2. So here, looking at the first quantity that's being squared, cosine theta, sine theta times cosine theta minus sine theta. So I'm just going to square and expand out each quantity first alone. So cosine times cosines, cosine squared minus cosine sine minus cosine sine plus sine squared. Combine your like terms. Cosine squared minus 2 cosine theta sine theta plus sine squared theta. So that's my first parentheses. And the second one will give me something similar. All right, fold that out. That'll be cosine squared. Cosine sine. Cosine sine. Sine squared. Once again, we got like terms in the middle. So that's cosine squared plus 2 cosine theta sine theta sine squared theta. All right, so before we add them together, questions. All we did was expand them out, foil them out.
Just go up just a little bit.
That's it right there. we can put these together now. All right, so let's put them all together. Of course, I ran out of room on that right side, so I brought it down bottom. So we can combine our like terms. Got cosine squared plus cosine squared. That's 2 cosine squared. Then we have negative cosine sine plus negative 2 cosine sine, then positive 2 cosine sine. And then we have sine squared plus sine squared. That's 2 sine squared. Now I can factor out 2. And then 2 times cosine squared sine squared. Don't forget that is equal to 1. So 2 times 1 is 2. All right, let's see. Any questions on anything? All right. Well, we can start right here unless somebody want to see another one. Yep. Like I said, try these out. See if you get stuck on any of them. And of course, if you do, feel free to bring it to class and we can go over it. And we'll go from there. Questions, concerns, comments. Like I said, the test is up. It's been posted. So you should be able to see it now. And somebody saying something to me?
I got hand cramps now.
Oh. I don't know if I should say sorry, you're welcome, or but yep. So if you guys are good, I'm good. And I will see you next class, and we will jump into 6-2. All right. Everybody have a good one. Oh, I see somebody in the chat.
Take care now.
Thank you. All right, you take care. Do the same.